All right. Hello, all of you awesome, brilliant geometry students. This is our review for our upcoming test on section 4 and 5, as you can see right here, although it really includes a lot of topics from section 2, transformations. So go ahead and get started. If two polygons are similar, then corresponding sides must be, we know this is proportional, okay, and the corresponding angles must then be congruent. Okay, we want to match the description with all applicable transformations. All right, write the definition and match the transformation to the right. Okay, you guys can write these definitions down, but we know that rigid motion, we have no change in size, okay? That would have to include reflection, rotation, and translation. Non-rigid motion means we know this is a change in size, and that would be a dilation. Congruency transformation means that the shape is congruent after it's been moved, so congruent after transformation. And if it's congruent after, then the only ones it could be is reflection, rotation, and translation. Similarity is it's similar after it moves, okay, similar after transformation. And let's see, similar after transformation means the only one that would be similar but not congruent would be dilation. Preserves angle measure, they all preserve angle measure, all right? And preserves distance. So we're talking about the distance between the points in the object. So because the dilation changes the shape's size, it can only be reflection, rotation, and translation. Okay, triangle TAG is graphed as shown. Which of the following transformations will move TAG so that the point A is at the origin? Okay, so move point A so that it's at the origin. Well, point A is right here, and it'd be right 2 horizontally, 2, and down 2 vertically. So that's plus 2 for the horizontal and minus 2 or down 2 for the vertical for the Y. Okay, Jesse's living room is rectangular and it has dimensions of 45 by 60. Jesse is planning to set up a play area for her new baby. The play area will be a similar rectangle with a scale factor of 3/4. How many feet of baby gate will she need to enclose the baby area on all 4 sides? Well, it sounds like they're asking for the perimeter of the baby area. Okay, I'm just going to draw that right here. So it was 45, her living room's 45 by 60, and we are multiplying this by 3/4, 3/4. Okay, so that means that it should be shrinking because your dilation or your scale factor is less than 1. So we do clear this out. We have 60 times 0.75. That's what 3/4 is equal to. So that's 45. And that would also mean this side's 45. And then we do our 45 times 0.75. So that's 33.75. And this side's 33.75. So if we want a perimeter, we need to add up all 4 sides. So 33.75 plus 75 plus 45 equals the perimeter of the baby gate would be 157.5 feet. Okay? All right. The sum of the internal angles of a regular polygon is 1080. How many sides does it have? Okay, well, we have the sum of internal angles, and we know that formula. The sum of internal angles is we set the internal angles, so 10, the sum, 1080, equal to n minus 2 times 180. And we use this formula again because we know that our variable n is number of sides, and we want to solve for the how many sides it has, the number of sides. So we're going to start by dividing by 180. Divide by 180, and that will give us, so 1080 divided by 180, be really careful, is 6 is equal to n minus 2. We're going to add 2 and add 2. That means that n equals 8. Okay? So it has 8 sides. There was no blank there for you guys. What is the measure of one of the internal angles? Okay, that means all the internal angles are equal to 1080, and all the internal angles are congruent because it's a regular polygon. So we take our 1080, and we divide it by our number of sides, which is 8, which gives us 135. Okay, so this is 135, and what is the measure of one external angle? Well, we know one internal angle and one external angle have to be supplementary. Okay, they have to be equal to 180. So 180 minus 135 is 45. And you could have also taken 360 and divided it by 8 and also found that was 45. That's another way of finding one exterior angle of a regular polygon. Okay, new question. If the sum, where are we here? If the sum of exterior angles is half the sum of the interior angles of a polygon, how many sides does it have? Ooh, okay. Let's see. We have sum of interior angles of a polygon. Well, what are our choices for the sum of interior angles of a polygon? And our choices for the interior angles, well, let's see. The smallest it could be is 180, and then our next option would be, after 180 we have, let's see, 360, and then we have, after 360 we add on another, we have our next angle. So again, and these are coming from n minus 2 times 180, where n equals 3, n equals 3, so 3 minus 2 is 1, 1 times 180 is 180. And then we would plug in where n equals 4, so we have 4 minus 2 times 180, right? So 4 minus 2 is 2, 2 times 180 is 360. Then our next one, and this is in your book, 5 minus 2 in section 4 times 180. So the next one is, we have 3 times 180, and 3 times 180, you can see on your calculator, is 540, right? And then you can keep going. Okay, so these are our possible internal angles. And how many, we want to think about what the external angles are on any polygon. And the external angles always, so these are internal, and then external angles, always equals 360, right? Okay, so let's do one more. So I'm looking for a number that's twice as much as my external angles. Remember, it says if the sum of exterior angles, that's 360, is half the sum of the interior angles. Okay, so is this half of 340? Not yet. So what am I looking for? It looks like I'm looking for the next one, which would come from 6 minus 2 times 180, right? So 6 minus 2, so that's 4 times 180. So 4 times 180 is 720, okay? So 720, 720 is the sum of interior angles for a 6-sided polygon, and 720 is 2 times 360. So it says if the sum of exterior angles, that's 360, is half the sum of the internal angles, which is 720, then we have our answer. So it looks like, because 360 times 2 equals 720, okay, it looks like our sides, we have 6 sides. Whew, all right. So this was our answer because we were looking for this. Okay. All right, so number 7. The vertices of a rectangle are, and they give M, N, O, and P. A rotation about the origin maps N onto the point 1, 5. The rotation was a blank, and then we need to know if it was clockwise or counterclockwise. And then we want to know where the point O is. So this is quite a bit of a problem, actually, to be stuck in the center here. So you're going to need to use some graph paper, I believe, or at least it'll really help. Okay, so we'll go ahead and map this out. So the vertices of rectangle, all right, so we have -1, 2, 3, 4, 5, and then down 5. 1, 2, 3, 4, 5. Okay, so can't see that. Let's see, let's give us some more room. All right, so we have our point. This is M. N is -1, -5. That's N. O is -1, 1. And -5. P is -5, 1. 1, 2, 3, 4, 5, 1. Okay. And it turned out to be a rectangle. Let's see. Highlight it with a little orange. Okay. And a rotation about the origin maps in onto the point 1, 5. Okay. So we're looking at N. N is here. Remember, N is -1, -5. We want to know how N would become +1, +5. So +1, +5, this would be N prime. And it looks like that would be 90 would take us here, and 180 would take us here. So that's 180, it looks like. So that's 180 degree rotation. And which way? So this is 180 degrees. Which way did we have to go to get to 180? Well, with 180 degrees, you can go either way. Okay? So it's actually, it would be clockwise or counterclockwise. The point O is at where? So where's our point O? So we have to figure out where it's going to be after we rotate it 180 degrees. Okay. So right now, our point O is at -1, 1. O is at 1, 1. And we know our rule for 180 degrees is we switch the signs of both the x and the y. So that means that if we change a sign, this is -1. So if we change the sign of both, that would give us +1, -1. So if O is here, O prime, so 90 degrees would move it, and then 180 would move it here. Okay? So again, 90 would have moved it here, 180 moves it here. So this is O prime. So your point is at 1, -1. 1, -1. All right. Look at the diagram. Hexanol, or hexanol, is a regular heptagon. That's confusing. Hex and then heptagon. Okay, so we're not going to worry about the name of it, but we're going to worry about the fact it's a regular heptagon, which means it has 7 sides. And we need to find measures of angles P, Q, and R. Okay, so it's regular. It's a regular heptagon, so all sides are the same. So let's see. I can figure out what the sum of the internal angles are. So we would do, let's see, 7, right, minus 2 times 180 would give us, well, 7 minus 2 is 5. 5 times 180 is 900, right? So each internal angle would be 900 divided by 7, which equals 128.57. So this is 128.57. And I think this is supposed to be a capital P. Okay? So that means each one of our internal angles, this one, 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 they are all exactly the same, and they are all 128.57. Okay. Good there. So now we need to know Q. Well, if we know that P is 128.57, this one would also be 128.57. It didn't say what to round to. Let's say 128.6. So 128.6 here, that means its supplement would be 180. So 180 minus 128.6. So that's 51.4. 51.4. Okay. So we know, so this was 51.4, and now we're looking for R. Ooh, okay, how do we do R? So I'm going to turn my paper a little bit. So hopefully you can see that, get in focus, you can see that this is one of our internal angles. So this was 128, very small, 0.6. And this length must be the same as this length because this is a regular polygon, so all the sides are the same. So if these lengths are the same, and we know this, then, and we know a triangle equals 180, we know that this angle and this angle must share the remainder of 180. So we would take 180, subtract 128.6. All right, and so we know already that that equals 51.4, and then because R has to share the remainder, right, on both sides, we have to divide it by 2. So 51.4 divided by 2 is 25.7. All right. So, number 9. Number 9 corresponds to this picture right here. So, given A, and A is at negative 4, 0. This is A. And B is at 0, negative 6. That's here, B, and C is here. Okay. Using a scale factor of 7/3, or 7/3, we want ABC, so this is ABC, is dilated from the origin, so from the point of C actually, to form X, Y, Z. Okay, what are the coordinates of X and Z? So we need an X, Y for both X and Z. The question is which letter corresponds to which? So we want to match these up. So ABC, so we know, so A is going to be equal to, its dilation will be X, B will be Y, and C will be Z. Okay, so we're looking for A dilated to X, okay? So A, to get from the origin to A, we have a horizontal movement, right? So our horizontal movement is just negative 4, and our vertical movement is nothing. And we know we take these and we multiply them by our scale factor, which is 7/3, and then we 0 times 7/3. So our new point here, right, so instead of going negative 4, we're going to go, and that is equal to, so negative 4 times 7/3 is negative 28/3. Okay? And 0 times 7/3 is just 0. So our point is negative 28/3, comma 0. And our Z is our C. Okay, well, C is the point of dilation. There was no vertical or horizontal movement. Horizontal was 0, vertical was 0. So 0 times 7/3 is 0, and 0 times 7/3 is 0. So it ends up at 0, 0. Given A is at 2, 2, A A is 2, 2. We have B at 4, 6. And C is at 8, 6. Okay, so it looks like we have a triangle. All right, and our triangle is dilated by a scale factor of 1/2, and it's centered at 4, 2. Okay, let's see here. So 4 centered at 4, 2. So this is our center of dilation. Okay, so not coming from the origin, so a little bit different than when we go from the origin, right? We cannot just multiply everything by 1/2. Again, you cannot multiply each point by 1/2 because it is dilated from 4, 2. So instead, we start at 4, 2, and we're going to, oh, I didn't mark all my points, B and C. So when we go to A, right, A, B, and C, when we go to A, we have a horizontal movement of -2 and a vertical movement of 0. When we go to B, we have a horizontal movement of 0, but a vertical movement of 1, 2, 3, 4. And when we go to C, we have a horizontal movement of, what is this? 1, 2, 3, 4, so +4, and a vertical movement of 1, 2, 3, 4, the same as to B, so 4. Okay, and we want to take all these and we want to multiply all of them by our scale factors. Okay, so if we multiply them all by scale factors, -2 times 1/2 is -1. Ooh, it just went dark in here. All right. Automatic lights. 0 times 1/2 equals 0. 0 times 1/2, 0. 4 times 1/2, 2. 4 times 1/2, 2. 4 times 1/2, 2. All right. So, and we're going to start at the center. So instead of going left 2, right, horizontal of -2, we're going to go left 1. All right. And vertically none. So our new A prime would be right there. And then if we are going to B, instead of going up, or instead we have no horizontal movement, so nothing there. And then vertically, instead of going up 4, we're going to go up 2. And this is going to be B prime. And then for C, instead of going right 4, we're going to go right 2, okay? And then instead of going up 4, we're going to go up 2. So right, instead of going right 4, we're going to go right 2. Instead of going up 4, we're going to go up 2. So we're here. Okay. So if I make my little shape, oops, I don't know why I connected that. I want to show the projection lines. So here's my new shape. And you can see that it's a miniature version, right, of our bigger shape. And if I connect, if I want to show my dilation lines or my projection lines, I can connect my center to all of my projection lines, and it should line up. Makes it kind of crazy looking, but I know I did it right. Okay? So then what is the sum of the y coordinates? Okay, so this y coordinate was 2, so it was x, 2. This y coordinate here for B prime, that was x, 4. And then again for my C prime, it's also x, 4. So if I sum up my y's, I have 2 plus 4 plus 4 is 10. So 10 is our answer. Okay. All right, moving on. This is a very long test, as you can see, in a long review. So trying to push through. How many lines of symmetry does a pentagon have that will reflect onto itself? Okay, so we know a pentagon has 5 sides, and our number of lines of symmetry is the same as our number of sides. So easy one, 5. Okay. Given that ABC, all right, is, and this is what we use for similarity, similar to AED, and AD, so AD equals 5.5, that's already on here. What is the length of DC? Ooh, so we're looking for this little length here. We're looking for that little baby chunk, okay? All right, what is the length of DC, and write it as a decimal? Okay, so we want to figure out what the scale factor is. So if we are going from, we want to compare, so we have 2 triangles here, and they're oriented a different way, so we could break them apart, but we can also just compare them. So I can show you, if I wanted to orient it the same way, so this big one and this little small one, this is a 5.5 length here, and this bottom length is 4. So you can see that this length corresponds to this length, okay? And we're looking for this, to find this little bit here, we need to find the whole length and then subtract off the length we have right here, okay? So what is the dilation factor? Well, 4 to 6, right? So it looks like this is getting bigger. So 4 to 6, well, what is that ratio? So this is going to be our final, and this is our initial. So we'll do 6 over 4 is equal to 3/2, which equals to 1.5. So this triangle is been dilated by a scale factor of 1.5, which means that if we want the full length here, we would take 5.5 and multiply by 1.5. And we get that this whole thing here is 8.25. Okay, and so if we want the distance, this little chunk here, we would take 8.25 and subtract 5.5, because this is the difference between the long and the short, which gives us 2.75. That's a little messy, but that's 2.75. Okay. Given quadrilateral RSTQ, identify the coordinates of T prime after performing each of the following transformations. Okay, 180 degrees clockwise rotation around the origin. All right, so we just want to think about, you can either think about your rules, or you can think about, you can move your paper, however you do it. So our T coordinate is -2, 1, 2, 3, 3. And so if we are doing our clockwise rotation, remember clockwise rotation is x, y goes to -x, -y. And so it means we need to change the sign on the 2 and change the sign on the 3. So that would be 2, -3. Reflection over y equals x. So this is x, y. And it goes to, so when we do a reflection of y equals x, we know that we have to just switch the y and the x. So instead of it being -2, 3, it's going to be 3, -2. So 3, oop. Let's see. Sorry. Okay, so we have to switch them, right? So it's going to be 3, -2. Did I mark the wrong one? I marked the wrong. Oh, sorry. It's this one. Okay. Reflection over y equals -x, so that's x, y goes to -y, -x. So that means I need to change the sign on both of these and then flip or switch the order. So it's going to be, I'm going to have a +2 and a -3, and I need to switch the order. So it's going to be -3, +2, and that is this one. Okay. And then 90 degrees clockwise rotation around the origin. So you can either remember the rule, or you can just look at it and go, okay, this is at -2, 3. And if it's going counterclockwise, that means I expect it to be down here, right? I expect it to be in the first, second, third quadrant. So I would rotate my paper like this, 90 degrees, and I would replot -2, 3. 1, 2, 3. Okay? So that means that I'm at -3, -2. So -3, -2 is here, right? And then I have my last one, which is the reflection over the y-axis. And my reflection over the y-axis is just going, reflection over the x-axis. So that means that my T was up here, it's reflecting down, right? This is our rotisserie chicken. So it's going to go around my x-axis, which means that it's going to, if it was 3 above, it's going to be 3 below. 1, 2, 3, it's here, it's -2, -3. So -2, -3. Okay. That's that. So we want to look at, so we have our triangle RST, that's this one, and it's being translated to, RST is a translation image of ABC, okay? So it says that this is a translated image of ABC, so we're going like this. Right? We're starting here and going here. You want to make sure where you know where you're starting, where you're going, because that makes a difference on if you're going which direction you go first. So because we're starting, it says RST is a translation image. I think it means translated image of ABC. That this is our final and this is our initial. Okay? So we can pick any point we want to. I can pick A. So A corresponds to R. We can see R is the first letter and A is the first letter. So we're going to go right 1, 2, 3, 4, 5, 6, 7. So +7, and then 1, 2, 3, down 3. Okay. What is the angle of rotation that about the center that will map the regular hexagon onto itself? Well, our rule for this is we just take 360. And we divide it by how many sides we have. 360 divided by n. So 360 divided by n, and it has 6 sides. It's a regular hexagon. It has to be regular. 6, so 360 divided by 6 is 60. So it's 60, but it would also be what? 120, and then 180, and so on and so forth. You keep adding 60. So every multiple of 60, any multiple of 60. Okay. Consider the figure below. ABC, triangle ABC is translated using the vector. So this is how we describe movements, right? This is just a translation. I know they threw in a new vocabulary word. This is just a translation. And then rotated 180 degrees about the origin. What is the y-coordinate of A? What is the y-coordinate of, A prime? Okay. So, well, first of all, they're sort of testing your ability to figure out what your points are because they're missing a line, right? They're missing a line on here. So I'm going to fill that in. And they're also, be really careful, they're going by, if this is 4 here, they've marked it by 4s. Well, if this is 4, then this is 2, right? This is 2 here. So this A is between 2 and 0, which means A is at 1, okay? So A is at 1, comma, and this is 4, then this is 2, and between 4 and 2, that point A is at 1, comma, 3, okay? 1, comma, 3. So that's your first step in making sure that you know where you're going with this. All right. So here we go. What we need to do first, so ABC is translated using the vector and then rotated, okay? So we have our translation first and then a rotation. Okay, so we're starting here and we need to go it looks like left 3. So I'm going to subtract 3, so it's going to be 1, 2, 3, okay? So that puts us on negative 2. So A prime is at negative 2, and then I have to add 3. So 3 plus 3 is 6. Okay? So I was at, just a sec here. So I was at 1, 3, and then I ended up at negative 2, 6. Again, I translated my points, okay, or my point. So now I need to do a 180-degree rotation about the origin. Well, it doesn't matter which way I go, right, because it's 180. So if I'm, let's see, so I was 1, 2, so I was here. So my A prime is here, and now we need a 180-degree rotation, which just means that A prime prime, remember 180-degree rotation, so 180 rotation is x comma y goes to, and we just put negatives in front of them, or we sign change. Okay, so we need to sign change both of them. So if it was negative 2, 6, then we know we need to have positive 2, negative 6. And we can take a look at that. Positive 2, negative 6 would be right here. And that does indeed look 180 degrees about the origin. You can see. All right. Woo, last one. Oh, sorry. So the y coordinate of A prime prime is negative 6. There apparently was a typo here. It's D, but it should be negative 6. Okay. Point E with coordinates 4, 6 is translated along a glide reflection to its image E prime, and then negative 6, 8. So which best describes the glide reflection? All right. So our glide reflection is a reflection followed by a translation, or a translation followed by a reflection. And so, let's see, it looks like we're probably going to need to graph this one. So, let's get out my handy dandy graphing stamp. All right. Ooh, that is not dark enough. All right. So, okay, we're at 4, 6, 1, 2, 3, 4, up 6, 1, 2, 3, 4, 5, 6, ooh, right on the edge. This is 4, 6, and that was point E of some image we don't really know very much about. And we need to, it says, perform a glide reflection to find the image negative 6, 8. Which is the best? Which best describes the glide reflection? All right, so we need to figure out how we get from 4, 6 to negative 6, 8. Ooh, off our graph. 1, 2, 3, 4, 5, 6, but up 8 would be here, okay? So that's E prime at negative 6, 8. Okay. So it looks like, actually, maybe not too bad. If this was moved 2 more to the right and 2 up, that would give me, that'd be at 6, 8. And then all I'd have to do is reflect over the y-axis, and I'd be at my E prime. So it looks like it's a translation of 1, 2, up 1, 2. So a translation of 2, 2, followed by a reflection in the y-axis, not the x-axis, because the x-axis would bring this point down here. Okay? So it's B. And that's it. Good luck, everyone. Please let me know if you have any questions. Please come by my room if you're unsure about anything. Otherwise, good luck.